This lesson is going to be a continuation of the feature learn and feature transform video that I did earlier. And we'll show you how to split your data to create a model, to score your test data set, and to evaluate the performance of your model. Now, the first thing you're going to want to do is come over to here on the left and find the split transformer. And just connect it to your transformed data set after your feature transform. Very simply, you're going to set the training ratio to the test ratio, and 0.8 would mean that 80% of your data is going to be used to train on, while we'll test against 20% of your data, and we're just going to set the seed, which is going to be a multiplier that is going to be used for the split in order for the split to be consistent every time, so that when we're testing it over and over, if you keep splitting it, you're going to get the same split so that you don't get inconsistent results. And our outputs are already set by the split as training and test, and that looks good already. It's already being used elsewhere in the app, but we're not going to be running it, so it doesn't really matter right now. And so we're going to see the same exact data set in both. It's just that this training set is going to be 4 times bigger than the test. So same data set. We're going to be wanting to use this training data set in order to create our model on. And we have a couple of different options over here on the left that we can use for that. This is going to be a classification problem that we're going to be solving because our target column is simply just ones and zeros. As we can see up here, we're not doing any need for regression, and since we have a target column, we're not going to be clustering. So we could use logistic regression, or we could use decision trees, but I'm going to be using random forest for this demo. So we're just going to drag over random forest and connect it to our training data set and go into it. Now this will give you a lot of different options. You can find in Spark documentation, since this is run in Spark, you can see all of the various variables that you can set in the hyperparameters you can tune for your algorithm. I'm going to be using entropy, and you can set these according to whatever you want. Now in Syntasa, you can set multiple values in the fields that say supports comma separated values, and this is going to allow you to sample multiple different hyperparameters and mix them all up and test them all, so that you're not running a job and then retesting it and then retesting it and then retesting it. You can sample a lot of different ones, and then it's going to pick the best one for you, and it's going to print out the data on each one and tell you which one was the best model with the best hyperparameters. The mapping, you're going to tell it which columns we are going to bring into random forest and actually work on. So I'm just going to add them all because I'm not sure at this point which columns and fields are useful to find out what the target column is. And so with the label right here, I'm going to have to set what my target column is, and that's going to be all the way at the end on this data set called target that I have set. And then for features, I don't have to set yes to all of them, but in this case, I did take the time out to set yes on all of them because A, they're all numerics, and B, I don't know which ones are actually useful at this point. So rather than clicking yes on all of them right now, just know that when I ran it the first time, all of these were yes. As well, I'm carrying forward the exact same identifier as before, my MCVIS ID, and I'm partitioning on the same column, the event partition, and both need to be set to yes. My output table names, those are all set by default by the random forest processor. And this, after that, should be good to go in setting and running our random forest. When it's run, we're going to see some learning metrics and some feature importances in our model that we have here. We can examine some of the details of what it's learned, such as the important columns, the data was calculated on, in case it's really an old model that we ran a long time ago and it needs updating. Or we can look at some of the learning metrics, and this will tell you what were the metrics found on which model parameters. I only set one model parameter because I didn't do any comma separated values, but this would show one line or one row for each set of hyperparameters that you input in there, and it's going to tell you what the results were. What's the best model? Okay. After that, after we have a model, we're going to want to score it against our test data set and then eventually evaluate it. So for applying it to our test, we're going to go down and we're going to bring over our score processor. And we'll put it right here, and we will connect our test data set, and we're going to connect our model. And this is going to look at this data set blindly and try and guess what the target column is. Now let's add in all of our columns, and let's set our feature, our identifier, and our partition. So feature is going to be yes to everything. And then our identifier is, once again, our MCVISID, partitioned on the same column. So just click all of these yes, except for the target and the event partition. The output is already predetermined, and so we can run this and it will give us an output that's going to tell the weights on each prediction. Now this was an easy scenario for it to pick up on, and so it's very confidently telling us 100% that this user ID in this purchase, it's saying 100% we predict that it was not fraud. And so there's our target column, it's a 0, so it was correct on this, and this is just a preview. Once we've scored it, now we're going to have to see if those scores were actually accurate, and we're going to do that with our evaluator, which is right here. We will drag this over, and it's going to compare those predictions in that predictions column to the target column. And all you do is need to add a couple inputs for it to do so. So we have our prediction column, predictions, and then our label is our target column. Then our evaluator type is these multiple different evaluators that you'll find in Spark. And since we're dealing with only a 1 or a 0 in our target column, that's binary, and so we're gonna call in the binary class evaluator. And so we're just gonna click the check mark, and then we can run that one too. And what that will do is tell us very useful information about our model in order for us to consider deploying it to production or whether we should keep working on it. So you'll see your useful information such as your precision, your recall, measure, area under ROC, and such. And that's how you create and test a model in Syntasa. Later on, we'll be learning about how to deploy it into production in order for new data that's flowing in to be scored against with your model. All right, have a good one.